Hi, my name is Jackson Metz.
My name is Austin Lassiter.
My name is Matthew Bowe, and we created a self-charging robot for our junior design project.
We designed our robot to search for a specific colored block. It approaches random blocks found by the sonar and uses the color sensor to determine whether the block's color is the color that it is looking for. If it is the wrong color, the robot will back up and display wrong color on the LCD and begin searching for a new object. If it's the right color, the robot will back up and the LCD display will say object found. It will then begin searching for a new colored object, repeating the cycle.
When the battery is low, the robot will begin searching for the charging station. We used an IR emitter on the home base and an IR receiver on the robot to navigate to the base. The robot will rotate to find the IR light, allowing the robot to navigate to the charging station. When the robot is close to the charging station, we used a color-coordinated pad to help the robot navigate onto the charger. If the robot finds the red pad, then the robot is in the right place and is charging. Otherwise, if it finds the blue or green pad, it will back up and rotate to face the red pad.
Our robot also displays the distance traveled using rotary encoders and interrupts in the Arduino code. Our robot needed many components and sensors to work together to generate the movement we wanted. Each person in our group was responsible for different parts of the robot, and each part was equally important to the success of this project.
My contributions to this project were the IR emitter and receiver, the color sensor, and the motor and motor driver. The IR emitter and receiver allows our robot to navigate back to its charging station. The IR emitter uses a 555 timer to pulse an IR light at 28 kHz and an Arduino to pulse this modulated IR light at 50 millisecond bursts, where it will be received by the receiver on the robot. The receiver takes a digital input of 0 if the signal is caught and a 1 if the signal is not caught. Using this information, the robot can move forwards if the signal is caught, and it can rotate to find the signal otherwise. The color sensor is an integrated circuit called the TCS3200. It pulses a white light and contains an array of photodiodes, which are green, blue, or red filtered. The sensor will then convert the light intensity of each filtered color after a pulse of the white light to a PWM frequency waveform that will provide a distinct red, green, and blue value that the Arduino captures. From those values, we can determine the color of the object from close range, allowing the robot to determine if it has found the correct object or not. The motor and motor driver serve as the basis for the movement of the robot. The motors are controlled by a dual H-bridge motor driver, which has 2 pins for each motor that allow them to move either in a forwards or backwards direction. Additionally, it has 1 PWM pin for each motor that controls their average voltage, allowing the user to vary the speed of the motors. Overall, the H-bridge motor driver will allow the robot to move left, right, forwards, backwards, counterclockwise, clockwise at varying speeds.
My contributions to the project were the LCD, the power supply, and the encasing for both the base and the robot.
The LCD module was relatively simple. The LCD has I2C communication capabilities, so only 4 pins were needed from the Arduino. In the Arduino code, I was able to print messages and variables onto the screen using commands designed for the LCD. During normal robot operation, the LCD would display distance traveled on the top line and the colored block to be found on the bottom line. When the battery was low, the LCD would say low battery, and when the robot was charging, the LCD would say charging. The power supply includes the battery that powers the robot as well as the charger used to recharge the battery when the robot is connected to the base station. I used a 9.6 volt NIMH battery to power both the Arduino Mega and the motor controller. The Arduino is directly connected to the battery, but the motor controller couldn't take more than 7 volts. To fix this, I used a voltage regulator to knock the voltage provided down to the desired 7 volt level. Additionally, I used a few resistors to create a voltage divider so that we could use an analog pin on the Arduino to read the charge on the battery. Finally, I created the encasing for both the robot and the base station. I made the robot's encasing on SolidWorks. I designed it to hold several modules, including the sonar sensors, RGB sensor, IR sensor, and LCD. I also had to develop a method for attaching the encasing to the robot frame. I 3D printed the robot, and the printer made some of the edges rougher than we desired. To fix this, I added some wood filler into the cracks. This made the outside of the robot smoother, so when I finally applied the paint, it looked as good as we hoped. For the base station, I made the entire thing out of wood. The different colors in the base station are used to navigate our robot, so we sit on the charger in the perfect way. Red means our robot is centered, green means we're too far to the left, and blue means we're too far to the right.
My contributions to the robot included the ultrasonic sensors, the frame, and the microcontroller. My contributions to the robot included the ultrasonic sensors, the frame, and the microcontroller. The ultrasonic sensors are used for the robot to see and navigate its way to and around objects. The primary use of this module will be for the robot to find objects in an area and navigate itself close enough for the RGB sensor to work effectively. The module is sent a digital trigger to start a sonic pulse. When the pulse bounces back, an echo pulse is returned to the microcontroller, and the time between the trigger and the echo is used to calculate the distance that the robot is from an object. Two of these modules are used, one to sense objects on the left and one to sense objects on the right. The frame was designed to house most parts of the robot, such as a microcontroller, motors, shaft encoders, battery, power rails, PCBs, and the motor driver. It was designed to fit with the enclosure such that it would be easily accessible and hold the parts solidly. The microcontroller is an Elegoo ELCB003 Mega 2560R3 board. This module is used to control the robot. It reads the voltage level of the battery in order to tell when it should return to its charger. It controls the triggers that are sent to the sonic sensors, reads the IR receivers, controls the RGB sensor, and sends directions to the motor drivers.
Teamwork was a huge part of this project. As we mentioned before, everyone in this group contributed to the finished robot, and with so many components involved, it would have been nearly impossible to do it alone. Our group really enjoyed working together, and we spent entire days coding and tweaking the robot to get it to move the way we wanted it to.
Everyone needed to be experts at their specific parts, and we were all responsible for teaching each other the different modules we used. This allowed everyone to understand how the entire system operated rather than just understanding like individual contributions. I feel like this is important because it's useful to have knowledge in multiple fields, even if those fields aren't what you're best at.
Besides just the physical modules, everyone found a way to contribute to the final code used for the robot. The code was one of the more challenging aspects of this project, so having three minds working together to generate ideas was much easier than doing it all alone. Teamwork is crucial to creating a successful finished product, and we all developed our teamwork skills throughout the process of creating this robot. These skills will be extremely useful when working on future projects.
Overall, this project was a great learning experience for all of us. We knew we were challenging ourselves by creating this robot, but we also knew we were going to enjoy designing and developing the robot more than any of the other projects. We learned a lot about mechanical design, coding, and interfacing different parts to function well together, which will help us in industry or any other engineering-related career paths that we choose to take.
Everyone played a huge part in completing this robot and making it function the way we wanted it to. We gained plenty of teamwork experience, and we needed to use everyone's ideas to make the system work. This experience will be extremely important for any future group-related projects or collaborations that we work on.
In the end, we made a cool robot that can play hide and seek with colored blocks, move and measure specific distances, and recharge when its battery is low. There are many improvements that we could have made in hindsight, but we did the best we could given the time and knowledge we began with. We had fun creating it, and we're very happy with the way it turned out in the end.